Hi, welcome to a Konveyor meetup, guys. Today we will have Asier Cidon presenting on CI/CD pipeline tools. But before I give it over to him, I just want to go over three announcements. So the first announcement is and starting in March, we will no longer send out the calendar invite to Red Hat internal email list. We'll still send it out to those lists on the first meetup of the month, though. And this way, everyone who's already signed up for the Google group doesn't get the invite twice. The second announcement is if you're not part of the Google group and want to get invites to all these meetups and just want to hear big updates on the tools that we're working on, just sign up for the Google group. I'll put the link to it in the chat. And then the third announcement is if you have any migration stories of projects you worked on, feel free to send me an email and we'll get you on a meetup to present. It doesn't have to be Konveyor specific, like with any other tools. It also doesn't need to be any like vendor specific technology or Kubernetes flavor. It just needs to be migrated to Kubernetes. That's it. So with all that said, I'll go ahead and hand it over to Asier. Asier, it's all yours.
Hi, everyone. First of all, thank you, Jonathan, and thank you for attending. I'm sharing my screen right now. One moment. Can you see my screen?
Yep, everything looks good, Asier.
Okay. Well, we are here today to explore what native Kubernetes CI/CD pipelines are and how they can be useful for us. Okay. Let me start with a set of general concepts here. As you may know, Kubernetes is an open source container orchestration system for automating computer application deployment, scaling, and management. In summary, Kubernetes is a suite of programs to make developer code live, whatever the code is, and manage its lifecycle, test, deploy, build, etc. Well, Kubernetes was originally designed by Google and now is maintained by Cloud Native Computing Foundation. Cloud Native Computing Foundation ensure or look after the IT ecosystem evolution for cloud native software. For example, we can find there different projects, for example, Kubernetes, Prometheus, Helm, Fluentd, Envoy, and so on. Well, in this community, multiple companies are involved. For example, Red Hat, Microsoft, Amazon, Oracle, or Apple. Well, lastly, in this context, what is native? Native in this context is a concept of a solution which was designed especially for Kubernetes, okay? And we will throw the presentation. Well, my name is Asier. I'm a Red Hatter, and I joined Red Hat 2 years ago as cloud and automation consultant. I have been working with open source projects for 10 years, especially focusing on automation, development, Linux, virtualization, Linux, of course, and the last year development. Well, I'm passionate about DevOps practices, agile practices, containers, and new challenges. And for this reason, I'm here right now. What is the agenda for today? We will talk about general concepts and CI/CD landscape, and then we will talk about three tools: Tekton, ArgoCD, and Helm. And finally, we will have a real demo, okay? Well, what we have here is here we have a set of best practices which help IT companies to manage software development projects. Let me start with Agile. Agile is a framework which helps teams to deliver better value to a customer faster via an iterative approach to management projects, okay? Let's look at continuous integration. Continuous integration is a development practice where developers integrate code into a shared repository frequently. The idea is to have an automation process in order to automate the test and build application here, okay? Well, next we have continuous delivery and continuous deployment. Continuous delivery and continuous deployment are an extension of continuous integration, which helps developers to deploy these new applications in the different environments. Okay, the difference between continuous delivery and continuous deployment is that you have a specific manual step in continuous delivery in order to deploy this new application to production environments, while continuous deployment automate all procedures. Okay. Well, let's look at DevOps. DevOps is a set of practices that combine software development and IT operation in order to accelerate the continuous delivery processes. Well, testing-driven development, his acronyms are TDD, and is a style of programming where coding, testing, and design are still interwoven, interconnected. The idea is to think first in test and then implement the solution. This is the idea behind this concept. And finally, we have the pipelines. Pipelines are data processing elements connected in series, where one step output is the input of the network, no more than this logical set of tasks. Well, and what are the benefits of using these practices, frameworks, and so on? Well, the first is be focused on products. Take care of the company's strategic vision, focusing focusing our efforts on our product is totally key. Okay, spend time in the most important things is the key in order to have a good product. Okay, avoid or accelerate issues. The sooner you discover a problem, the sooner you can fix it. If you discover a problem early on your project, you may be able to prevent it from manifesting to something unmanageable. Okay. Well, one moment, please. All these practices ensure that our application comply with a level of quality, and for this thing, we need test our application in every step, and this is the idea here. And finally, reduce time to market. The idea behind all automation is to deliver products releases faster in order to improve customer satisfactions and innovation processes. This is the overall idea here. Well, the CI/CD landscape. We have a lot of continuous integration, continuous delivery deployment tools in the market. I don't know, for example, we have Jenkins, Bamboo, Travis, Airflow, CodeShip, CI/CD, GitLab, GitHub Actions. We have a lot. But when we need to define a solution, a CI/CD solution in our environment, we need we have some talents. At first, we need to choose one of these solutions, one or two, or depend on the situation. Well, design that, and then you need to design the architecture in order to implement a robust and scalable solution. And probably this is not easy. It is not easy. And finally, when you have your solution select and you are design your solution, you need to install and maintain it. Sorry. Well, what is cloud native? Cloud native is an approach for building and running application that takes cloud architecture advantage. The pillars of this practice are the teams, culture, and technology, with the objective of maximize productivity and velocity thanks to automated procedures. Okay. And why cloud native CI/CD? Why you need to use cloud native continuous integration, continuous delivery tools? Well, at first we have traditional CI/CD tools. These tools were designed for virtual machines and require some operation in order to maintain the CI engine, the continuous integration, in order to test our application, build our application, and then we need to maintain different plugins in order to talk with external solution, okay? And finally, we need to maintain a persistent storage or a system in order to persist our data. Well, with cloud-native CI/CD tools, the cloud-native CI/CD tools are designed or were designed for containers and Kubernetes. Here you have all your CI, continuous integration processes, integrated as a service in Kubernetes or in this solution. And the most important thing, probably is not the most, but an important thing is you have persistent delegated to the platform. Okay, if you are in Kubernetes, you have your persistent configured, and you are able to use this configuration easy. Okay. Well, continuous integration and continuous delivery deployment embody a culture, a set of cultures, practices, frameworks, and so on. But the idea is to enable application development teams to deliver code changes more frequently and reliably. And well, if you remember, Kubernetes is an open source container orchestration system for automating computer application deployment, scaling, and management. And well, if you have all your procedures integrated in Kubernetes, ensures the procedures benefit from Kubernetes features, auto-scaling, high availability, high performance probably, storage solutions. Okay, you have all this stuff integrated here in your solution, in your CI/CD solution, continuous integration and continuous delivery solution. Well, the technical stack. What is Tekton? Tekton is a tool, it's an open source project for creating continuous integration and continuous delivery deployment systems. It is important to know that Tekton provides open source components to help users to standardize their CI/CD tooling based on standards. For example, standards around pipelines, releases, workflow, test, and deployment strategies. You have a set of types of strategy types. For example, canary, blue, green, rolling, and well, Tekton helps you implementing this kind of strategies. And finally, it's important to bear in mind that Tekton is integrated in Kubernetes, but works with external tools as well. Okay, you are able to implement different integration with external systems. And well, other important thing here is Tekton provide a system of delegation which provides development teams autonomy and independence from other teams. Okay. Who does represent both CI/CD worlds? We have in the traditional CI/CD, we have Jenkins, is probably the most representative figure of these traditional CI/CD tools. And here in Cloud Native, we have Tekton and other new tools. Well, and I have talked a lot about Tekton, but the most important features for us here is you are able to configure Tekton, all components in Tekton. You can configure all components in Tekton with YAML files. That is the Kubernetes standard. Well, run serverless. All processes in Tekton are individual, and you don't need to have a specific server or manager to handle this sequence of tasks. Okay, and finally we have integrated CI/CD experience. Tekton is totally integrated with Kubernetes console, and it has different integration with command line clients and IDs, for example, Visual Studio Code. Okay, and well, we have in Tekton, or Tekton has different components, but regarding this presentation, the most important ones for us are step, is a command running in a container with a set of resources, for example, volumes and bars, etc. We have tasks. A task is a list of steps that run sequentially in same pod. When you execute in the same pod, the idea behind the same pod is you are able to share different resources, volumes and bars, etc., between all steps in a task. Okay, this is it's important to bear in mind that. And we have pipelines. Pipelines or pipeline is a graph of tasks executed in a specific order. And finally, we have triggers. Well, we have two kinds of triggers, manual triggers and API triggers. Well, the manual triggers are implemented in in Kubernetes on OpenShift console. Well, and the second one are APIs that Tekton provides you in order to notify or to have event listeners when you need to implement an external integration. Okay. Well, this is the Tekton console. Right. To be honest, is the OpenShift console, but Tekton is totally integrated here. And an important aspect here is we have Tekton and OpenShift, in this case, console integrated in order to have a unique point of administration. Okay. Well, ArgoCD. Basically, ArgoCD is implemented as a Kubernetes controller with continuously monitor running application in Kubernetes and control or compares the current state of this application in Kubernetes with a desired state defined in a GitHub or in a Git repository, GitHub, GitLab, or wherever. Well, the strategy is having a Git repository with a set of Kubernetes object definition and a mechanism to create these objects and control them in the final system, in this case, Kubernetes. Well, and why ArgoCD? Well, at first, increased productivity. Regarding application, ArgoCD improves continuous delivery and deployment processes. Next, we have simplify operations. ArgoCD reduces the number of tools and potential variables in infrastructure management and considerably reduce or simplifies the management infrastructure components. For example, you are able to configure run resources, CPU resources, quoras, and so on in a easy way. And finally, we have increased standardization. Well, automate procedures promotes standardization and simplifies the H2 operation, improving productivity, quality, while reducing errors. And it's important to bear this aspect in mind. Well, ArgoCD has some components as well, but the most important ones for us in this presentation are application, is no more than a group of Kubernetes resources as defined by a manifest. Sync, the process of making an application move to its target state in our GitHub or repository, code repository in Kubernetes. This is the sync process. Well, ArgoCD, this is the ArgoCD console. We have a specific console in order to manage ArgoCD objects. Here we have, if you take a look here, we have 3 applications right now. Okay, this is only a screenshot. And if you take a look inside one application in Argo, you are able to see all objects created, okay, and the state of each object. And finally, we have Helm. According to Helm official webpage, Helm is the best way to find, share, and use software built for Kubernetes. And basically, Helm is a tool for installing and managing Kubernetes applications. Well, think of it like a package manager, like apt, Yum, Homebrew, or Chocolatery, but for Kubernetes. Okay, this is the main idea behind Helm. Well, and the most important components here for us are chart. A chart is a Helm package which contains all of the resources definitions necessary to run an application in Kubernetes. The repository is the place where we share or collect our charts, and the templates generate the manifest files with our YAML formatted resources description that Kubernetes can understand. Okay, and well, this is the probably the funny part of the presentation for me. Well, just a reminder. There is not a perfect CI, continuous integration, continuous delivery workflow, or a silver bullet. Okay, in this demo, we decided to integrate our solution in a specific way, in a specific approach, but other requirements probably force others to have different implementation. And in my opinion, the most important feature in our CI/CD solution will be the flexibility. Okay, taking into account our priority is to have the better integration possible with all pieces involved in the CI/CD workflow with a minimum of operation time. This is the main idea, and you are able to have different approaches. Okay. Well, YAML. During this demo, we will lean on a demo application. Okay, named YAML. The name of this application is YAML. YAML is no more than a testing application which allows users to generate traffic inside our application. This application is based on 4 microservices or 4 modules, 4 pieces in different programming languages: JavaScript, Java, Python, and Golang. And well, we have a front-end, a front-end based on React. It's a JavaScript framework, and 3 backends. This backend exposes an API in order to make able this communication between all pieces. Okay, and it's important to know that each microservice has a specific repository in order to save the code individually. Okay. Well, Red Hat OpenShift is an hybrid cloud open source contained application platform based on Kubernetes. Okay, this is the platform that we will use for our demonstration. Okay, and in this demo we will work with OpenShift and with the following component installed in this cluster. Okay, before this presentation: ArgoCD operator and ArgoCD server, Tekton operator, and a set of Kubernetes resources in an namespace in Kubernetes in order to in order to have the pipelines and build config images and so on. Okay, don't worry, because we will explain this in some slides. Don't worry. Well, in this demo, we will throw 3 important steps or phases. We will have the deployment workflow, GitOps workflow, and CI/CD, continuous integration, continuous deployment workflow. Well, in the first steps in deployment workflow, we will deploy our YAML app application in Kubernetes using ArgoCD and Helm in order to be able to access to the front end microservice. Okay, the front end web UI. Well, then we will make a change in our application settings located in a GitHub repository, and then ArgoCD will apply these changes for us automatically. And finally, the CI/CD, or continuous integration, continuous deployment workflow, that we will introduce a modification in a front-end microservice. Well, and the idea here is Tekton trigger a pipeline in order to deploy this new version of our microservice. Well, the deployment workflow, as I said, in this step, we will deploy our application for microservices. If you remember, JavaScript, Java, Golang, and Python, okay, in Kubernetes. Well, if we go to Argo CD, to Argo CD, we have here our console. Okay, can you see Argo CD, the Argo CD console, Jonathan?
Yes, Asier.
Okay, thank you. Well, we need to create a new application here. Well, this new application is no more than a reference to a GitHub repository. Well, we need to fill out here some fields. Okay, we need to introduce the application name. Is no more than a name in Argo CD. We need to select a project. For me, it's JanaApp right now. Sync policy is automatic. Well, and we need to put here the repository URL. In my case, I have a GitHub repository. The name is JanaApp GitOps. And we need to, here we have different Helm automation charts. And we need to copy this URL here. Okay. We need to include the revision. Revision is the branch. Normally, you have one branch or two branches. You have developed a master, for example, but here we have a different approach. We have a branch for each application because for each, no application, for each environment. Why? We need to have different configuration in dev, in pre, and production environment. And for this reason, I'm using here the different branches. But you are able to have other approach. For example, to have different repositories, to have different files in a same repository. You are able to have different approaches. Okay, but for me, for this demonstration, I think it's clear to have one branch for application, for environment, sorry. Well, when you put here the URL and the revision, automatically Argo CD download the code, okay? And in this case, you are able to select a specific chart, but right now I'm using the root path, okay? Well, and finally, we need to define the cluster URL. This is the cluster when you want to deploy this application. In this case, is Kubernetes default service. That is the local namespace, the local cluster, sorry. And then you need to put the namespace. If you probably you know this information, but a namespace in Kubernetes is a virtual data, is a virtual cluster inside your physical cluster, where you have isolated resources. Okay, and you probably don't share nothing with other namespaces. You are totally isolated. Well, if we go back to Offensive Console, we have here different projects, and we have here the JanaApp dev. If you take a look here, we have zero deployment config, zero object in general. Okay, it's only to display this evidence. Well, when we have all fields filled, we can create the application, and well, automatically Argo CD download the application code and apply these objects in Kubernetes. Okay, backing back to the presentation. Sorry, in order to have the overall process here summarized, we have here the big picture of this process, only to summarize, just for reminder. Okay, we have the GitHub repository. For me, is the GitOps, is the name of this repository with the Helm automation charts. Okay, and then we have Argo CD. Argo CD pulls this change automatically, and then when we created this application, Argo CD automatically apply these objects via Helm in Kubernetes. This is the idea of this workflow. Okay. Well, if we go back to Argo CD, right now the application is healthy. We have here 3 boxes with important information. At first, we have healthy. This box is the health status, and this is the status of all application in Kubernetes. Right now, if you have all resources created and okay in Kubernetes, this state is healthy. Okay, we have here the sync status. The sync status shows if the desired state in the Git repository is synchronized with the current status in Kubernetes. Okay, it's no more. And finally, we have this box here that explains the last synchronization process. For example, I don't know right now because it's other application. Yeah, well, because this status process is succeed right now. 2 minutes ago, authorized by the author is my name, and so on. Okay, perfect. If we go to OpenShift console, we have here 5 deployments, for example, 5 pods, 5 services. Here we go. We have our application. In our application, if you remember, we have a specific front end. Well, if I visit the URL, JavaScript Jam app, I think, okay. Okay, perfect. This is my application here, the Jam application deployed, and you are able to jump. Okay, this is a request from this machine to Golang, and then to Spring Boot, and then to Python. Okay, and this is the response. Well, perfect. If we go back to the presentation, we have the GitOps workflow. In the GitOps workflow, we make a change in our application settings in GitHub, and then Argo CD applies automatically these changes for us. Okay, go ahead. If we go to Jam App GitOps, and we need to select our branch, we have here a file. This is the value file. Here we have the attributes of all microservices. Okay, here. Well, if you take a look here, we have the global variables, and here in apps we have different old applications, the JavaScript, Golang, Python, and Spring Boot microservices, and we have here some properties. Okay, one of these properties are replicas. Okay, well, if we want to modify this, I don't know, we can put here 2 replicas in all microservices, for example. Well, and we need to commit these changes. Okay, perfect, and commit change. Well, the idea here or behind this process is that Argo CD will detect automatically these changes and modify the current status on Kubernetes. Okay, if we take a look right now in Argo CD, yeah, right now it's waiting for new changes. Okay, if we go to the presentation right now. If you remember, this is just to review. This is the big picture, okay? We make a change in GitHub repository. ArgoCD pull these changes automatically and then modify, in this case, different deployments in order to increase the number of replicas, okay? Well, ArgoCD is healthy right now. A scale down to 1 replicas. We can refresh, but I don't know. I think this process is refreshed every minute, but probably we're able to refresh right now. Right now is auto sync because you have difference between the desired state and the defined state in Kubernetes. And well, when this process finished, we're able to see this change in our OpenShift console. Okay, we have here 2 pods in each deployment, and right now we have less than a minute ago 1 new replica running. Okay, in each service. Well, and I think it is working right now. Perfect, it's working. Well, and that's all about the Kubernetes, the GitHub GitOps workflow. And then finally, we have the CI/CD workflow, the continuous integration, continuous deployment workflow. Well, lastly, well, if you remember, continuous integration and continuous deployment embody a set of cultures and practices and so on. And the idea behind CI/CD is deliver code changes more frequently and reliably. Okay, and well, the main objective of this process is to make a change in a microservice repository, in the code of this repository, well, and promote this change to development environment in Kubernetes automatically using Tekton. Okay. Well, if you remember, we talked about triggers in Tekton. We have 2 kinds of triggers in Tekton: manually triggers in console and API triggers. And well, we will configure GitHub in order to notify automatically Tekton with each new event. Okay, in this case, with each new push event. Okay. Well, if we go to OpenShift console, here in Jump Up CI/CD, this is the CI/CD project, we have some roles, okay? And we have 1 API published per microservice, okay? In this case, we will make a change in our frontend, okay? And we need to copy this URL. Okay, if we go to our application in GitHub, we have here some settings, okay? And in this section, we have webhooks. Well, webhooks allow external services to be notified when certain events happen. Okay, perfect. We need to edit this. One moment. We need to edit. Oh my goodness. I forgot my password. Come on, please. Well, we need to copy, to paste our URL here, the JavaScript URL. It's important to put the correct URL here, and we need to update the webhook, okay, with the new URL. It's important to know that Tekton needs JSON bodies, okay, because when you push this new change, when you push a new commit, GitHub emits a new or make a post request, and the idea is to include a body, and this body needs to be in JSON format. Okay. Well, we have the code. We are working with the development with the development environment, and we need to modify the develop branch. Okay. We have here GitHub, GitOps, no, Gitflow, this is the name, okay, of this strategy. Well, and if we go to service UI header, we need here modify the version of this application, okay? Right now, we have Janap 2.0, and then we want to update the new version, okay? Updated to version 2.1, okay? Commit change. Okay, when the webhook is properly configured, we are able to make the change in our code, and GitHub will trigger Tekton Pipelines automatically. Okay, if we go to pipelines in OpenShift console, we are able to see here the pipeline. We have here some pipeline, and then we have a new pipeline launched, okay, or triggered. Well, we have here the same pipeline for pre-production and production environment and development environment, okay? And here, in this point, we have a condition, and if you are in a master branch, you follow this path, but if you are in the develop branch, you follow this one, okay? And you, first of all, you need to test the application, and then you have different steps here. The idea here is we implement this approach, but you have other approaches. You are able to have one pipeline per different environment and or different approaches. Okay, don't worry about it. And well, if we go to pipeline runs, right now here we have a new pipeline running. Okay, right now it's installing and testing. Well, if we go to the presentation again, sorry for the jumps, but here, just for a reminder, here we have the big picture, okay? And in order to summarize, the process is the developer modify the microservice source code and commit the new change, okay? Then ArgoCD webhooks, well, no, in this case, GitHub webhooks notifies ArgoCD, okay? ArgoCD trigger a new pipeline. In this pipeline, we have different steps. Git clone is download the code repository, the code source code from the repository, download dependencies, run app test, compile the application, build a new image, and here, when you have a new image built, you finish the continuous integration process, okay? And then we start, or Tekton starts with the continuous development, in this case, deployment process. Well, after passing the continuous integration step, Tekton modifies the front-end microservice parameters in ArgoCD in order to add a new image reference, okay? And finally, ArgoCD applies these changes automatically in the microservice deployment in order to have this new release deployed to Kubernetes, okay, in Kubernetes. Well, probably this CI/CD workflow, continuous integration, continuous deployment workflow, makes sense for you. But, however, it is not the only scenario, the only one scenario, okay? We have here, for example, we have simpler and better possible scenarios. For example, in the simpler scenario, we are able, or we have a direct integration between Tekton and Kubernetes. You are able, for example, here to notify from Tekton to Kubernetes automatically to change this reference, okay, this image reference. But the problem here is that ArgoCD will not be able or will not notify from these changes, and it moves the sync status process in ArgoCD to auto sync, and it is a problem. You can do it, but it's not the best idea. And well, we have here, probably in my opinion, the best scenario here, this is not the demo scenario, but in my opinion is the best. Well, in this scenario, we have a more comprehensive integration between Tekton and Argo CD. And well, the idea here is Tekton integrate the new change in a GitHub repository, in the GitOps repository, and then Argo CD pulls automatically this change and apply this change to Kubernetes. And why I'm showing you these scenarios? Okay, because if you remember, you don't have one approach here. You have multiple ways to work with CI/CD toolings or workflows. And the idea is to be flexible in order to have this kind of integration in a flexible way, you know. And yeah, finally, if we go to in order to finish this presentation, if we go to OpenShift console, probably, OpenShift console to review the pipeline run. Right now is in application is okay. The image is built. Okay. Well, we have probably some minutes more, and well, one moment. Well, I think we are finished. Sorry, because we are able to spend one more time, one minute more. But thank you. We will review in few seconds the console, but only to give you this information. I know we don't have a lot of time right now to answer questions, but here you have my email address and my Twitter account. Okay. If you have any question, let me know by email or chat, or I think Jonathan shared with you the Google group. Okay, don't worry, no worries. Ask me, and I promise I will respond to you. Okay. Well, perfect. Right now, sorry, the image is built. Okay, and the image is tagged. Right now, Tekton is talking with Argo CD in order to change this setting. Okay. Well, if we review, Tekton is progressing because we made this change in Argo CD. And if you take a look here, right now the pod is changing. Okay. Well, when the status is healthy, I think if we review the YANAB dev, and we have here the pods. Okay. The container is creating. Here we are using the rollout strategy. What is this? In this case, Kubernetes ensures that that we have all replicas scale, all replicas running with the new version to scale down the last version, the previous version. Okay, and right now we have the 2 replicas running right now, and I think we have here a new version of our application. Okay, and if you push in jump, all is okay and all is working. Thank you. That's all about the presentation. Thank you so much for attending. And well, Jonathan, you have any questions?
Yeah, we have a good amount. Thank you so much, Asier. So I'll start off with the first one. Could you explain the difference between DevOps and GitOps?
Yeah, I think DevOps is a more general concept. DevOps is the framework of all practices regard to IT development team and operation teams. And GitOps is only a strategy to have our definitions in a specific repository, okay, in code. This is the idea here.
Okay. The next question is, can Argo CD be configured using Kubernetes like YAMLs?
Yeah, of course. Argo CD use Helm in order to apply the Kubernetes objects. And in Helm, you have the manifest, you have the template, and the template is no more than a YAML file. For example, I can display you one example in order to clarify this aspect, but it easy. For example, we have here the YAML GitOps template, repository, sorry, and here we have different charts. And well, in these charts, for example, YAML micros, we have different templates, and this template is no more than a Kubernetes object in YAML way, no, in YAML file, in a YAML file, and you have different parameters here in order to when you renderize this application or this object to have a specific parameter. Okay.
Okay. No, thank you for going a little bit deeper into that. The next question is, how do you handle the problem of secret management when deploying apps with Argo CD?
The secret management, you are able to configure secret with the same, you have a specific module to manage secrets in Argo CD. I'm not sure about this, but I think you are able to handle secrets as other objects in Kubernetes. I think it's not a big problem, but to be honest, I don't have the specific answer here.
Okay. The next question is, can Git trigger Argo CD workflow when a commit is done?
No. Argo CD pull automatically. As far as I know, Argo CD has a process, a pulling process, in order to know when a commit is performed. But I think you are not using Argo CD because you don't have a specific API, I think, but I'm not sure.
Okay. And then the last question we have here is, can you provide a Git link?
Yeah, of course. Oh,
can you actually can you put it in the chat?
Yeah, perfect. Don't worry. We have here the GitOps repository, but this is the GitOps repository. But we have here the docs, YAML docs, I think is the name. This is the name. Docs, I think. Yeah, well. Here you can find the old documentation. Okay.
Okay.
Because we have here integration with service mesh and other stuff. Well, if you have any question, please contact me. Don't worry.
And then we have one more question. This is kind of trying to get a bit more clarification on an earlier question. So on the Argo CD configuration question, can Argo CD application be created using Kubernetes custom resource YAMLs? Is there a custom resource for Argo CD exists, just like pipeline custom resource exists for Tekton?
Yeah, you need to install the operators. You need to previous with Argo. You need to install the operator, Argo CD operator, and then you need to install Argo CD server. And okay. You have different components in Argo CD architecture. You have different components, and then you need to install in my case Red Hat OpenShift pipelines, but the name is Tekton operator. Is for most common for Kubernetes environment.
Ashok, if that didn't answer your question, feel free to put another question in here. And this is another follow-on question, but this is in regards to the secret management, the problem with secret management. Yeah. They are asking, Pia is asking, if an application needs database credentials stored in an OpenShift secret, and the application is deployed using Argo CD, how do you provide the secret to the application? You wouldn't store the secret in GitHub, B64 encoded or otherwise.
Yeah, you need a parallel process to create this stuff in Kubernetes. I think it's the best option to create this stuff in Kubernetes and then use it from Github, from ArgoCD, Tekton, or wherever.
Okay, and I think that's all the questions. Asier,
Yeah.
thank you. Everyone, thank you for attending. Just to like let us know how we did, I put the survey link in the chat, and that way we know like what we can improve on. And if you have any more questions, feel free to email Asier. And
Yeah,
that's
please.
it for today, guys. Asier, anything
Okay.
else that you want to point people to?
No. Thank you, Rogelio, because he's talking about the sealed secret, and thank you for the answer in the chat. Rogelio, thank you.
All right, guys. Well, hope you enjoy
Okay.
the rest of your day, and until later. Ciao.
Okay. Thank you, Jonathan. Bye bye. Bye, guys.